Okay, guys, today we're going to try to look at isosceles and equilateral triangles. So we want to basically use and apply properties of those two things. So first, let's talk about what an isosceles triangle is. You guys are probably familiar with seeing triangles like this. All an isosceles triangle is a triangle with at least two sides congruent. Now, at least two implies it could be three, but in general, isosceles triangles, we usually think about them just having two sides congruent. There's some nomenclature, though, that needs to go along with that. Do you guys happen to know, in fact, let's go back one. No, I should probably just tell you this. The legs of an isosceles triangle, they are the two congruent sides. Of course, again, it could be three. And in this case, that would be segment AB and segment BC. Those are the legs. The legs of an isosceles triangle are the two congruent sides. So if these are the legs, the congruent sides, this third side here, we actually call that the base. This down here is called the base. I guess I should write this up here too. This is a leg, and this is a leg. The base in this example is segment AC. It's typically the non-congruent side of the isosceles triangle. So when you hear the terms legs or base, that's what that means. Now the base, anybody want to take a stab on what they think the base angles are?
A and C.
You got it. So this angle here and this angle here, angle A and angle C, these are called the base angles. This is a base angle, and this here is a base angle. And the reason they're base angles is because they are the angles that touch the base. Anybody know what we call angle B? Don't look at your notes. You'll see the word. What's angle B called? It is called the vertex. This guy up here is the vertex or the vertex angle. Okay, so those are just some words you might hear me use, or you might see on a homework problem or a quiz question or something like that. I just need you to be kind of familiar with that. So the legs are the congruent sides. The base is the non-congruent side. The base angles touch the base side, and the vertex angle is formed by the two legs. Anyways, so that's just some nomenclature. This is probably, in fact, I think it is, this is the most important theorem in this particular section. It basically, it and its converse, which we'll talk about next. It is called the isosceles triangle theorem. You'll often hear me refer to it as ITT. So we abbreviate everything in this class, and we abbreviate that. You can write out isosceles triangle theorem, but most of the time people will just call it ITT. Here's what it says. If two sides of a triangle are congruent, so this side's congruent to this side, then the opposite angles of those sides are congruent. In other words, if this side is congruent to this side, then the base angles are congruent. That's basically what it's saying. So here's, what's the angle opposite this side? Well, if you put a little arrow there, that'd be angle B, correct? And if you put a little arrow opposite that side, that'd be angle A. So here's what the theorem says again. If two sides of a triangle are congruent, then the base angles are congruent. In other words, if the triangle is an isosceles triangle, then the base angles are congruent. Okay, so I'm actually going to make a comment here that's going to make me seem like a horrible person, but I'm going to say it anyways. This is an example of a problem where in the past when I've taught this class, if a student can't tell me the answer to this, I just really struggle with how to help them. Right? So let's see if, you tell me if that makes sense. What does X have to be?
That's equal to 180, right?
The whole thing does, yeah, the whole thing. But I'll give you a hint. What's this angle here measure?
It's the same thing.
75. So what's X?
75.
It's 75. That's it. It's just, you can almost just look at that and tell, can't you? That's the answer. So determine the value of X. x is 75, and you could put because of ITT. Since two sides are congruent, this side and this side, then their opposite angles have to be congruent. So if that angle on the right, that base angle on the right is 75 degrees, then the angle on the left also has to be 75 degrees. Now, do you guys understand why I feel like that's like one of the easiest questions we could ask? I just think it seems very simple to me. What do you guys think? Simple? Yeah, okay, good. All right, so don't miss that one. That's an easy one, right? That's an easy one. Now, here's the thing, though. Things get a little trickier on this one. It's not a lot harder, and it's going to go back to actually something that Nolan just said a second ago. So do you see we have an isosceles triangle again? This time I put it down kind of on one of its legs. It's kind of fallen down, if you will. It's on its side. It doesn't have to be oriented vertically. Is x 75 here?
No.
No. What's this angle up here? That one's 75. So here's my question. How are you going to figure out what this guy is?
75 plus 75 minus by 180.
You got it. That's exactly right. 75 plus 75. I'm going to show a little bit more work, but it's the exact same thing that you just said. 75 plus x equals 180. That's by the triangle angle sum theorem. That goes way back to a previous chapter. All three angles of the triangle always add up to 180. So x, like Nolan said, is just 180 minus 75 minus 75. So x in this case is, I think it's 30. I think it's 30. 30-degree angle. Got it? So that one was a little bit harder, right? You probably, I don't know. Could you guys do that one in your head? Think you guys could figure out the 30 in your head? Maybe? Okay. Be careful though. Don't rush too quickly through one of these and mess up one. Any comments or questions so far? So far, so good? Well, you doing okay?
Yeah.
Okay. So far, I think this is a pretty easy lesson, don't you? I don't think it's super hard. All right, so remember when we talked about converses, right? Remember P arrow Q, or P, if P then Q? What's the converse if P then Q? If this is a conditional statement, what would
P.
You got it. Q implies P. Now remember, the last theorem we looked at, ITT, said if the sides are congruent, then the base angles are congruent, right? This one says just the opposite, the converse. It says if the base angles are congruent, guess what we can conclude? The opposite sides are congruent. So this is called the converse of the isosceles triangle theorem. You'll sometimes see me write it as converse ITT. This is kind of a shorthand way of writing it. If two angles of a triangle are congruent, then their opposite angles are congruent. Did I just say that incorrectly? Oh, yeah, that's good. Okay, good. Moving on. Okay, this is an interesting problem. It's not a hard problem, but this is a problem where I've got, I'll just shut up. Anybody want to tell me what x is in this problem based on the picture? Raise your hand if you think you can tell me what x is. What is x? Say again, Jennifer?
1.
1? So Jennifer thinks that x is 1. Marvin, what do you think? Think it's 1 or something else?
Something else.
Something else? Okay. Nolan, what do you think? What do you think x is?
Not 1.
Not 1? Okay. Law, what do you think, buddy? You think it's 1? So I like this question because this is something we don't do enough of, I think, in math. Is you see this 8 up here? Guess what this has to do with this problem? Absolutely nothing. In fact, this whole triangle over here, you can just erase it because it doesn't have anything to do with that triangle over here on the right. This triangle on the right is the one we need to be concerned about. Now, do you guys see how this angle is marked congruent to this angle? If that's the case, then the sides opposite that angle have to be congruent. In other words, this has to be true about those two things. They have to be equal. In other words, what I'm saying is 9 has to be equal to negative 1 plus x. How do we solve that equation? You what? You plus 1. That's exactly what you do, Lal. You plus 1 on both sides, and you will get a final answer of x equals 10. X is equal to 10 in this problem. And by the way, this is by the converse of the isosceles triangle theorem. The converse of the isosceles triangle theorem. Okay? Any comments or questions on that one? Okay, let's go ahead and move on to the next slide here. Do you guys know what an equilateral triangle is? This is an equilateral triangle.
All sides are equal.
Correct. Do you guys know what equi kind of sounds? Kind of sounds like equal, doesn't it? Now here's a harder question. Do you guys know what the word? Have you guys ever studied like the word lateral? Do you know what lateral means? Like lateral raises?
Lateral quickness.
No. Well, the same idea, but it's what does that lateral mean?
Side to side.
Side. That's exactly what it means. So this means equal sides. All three sides are equal. That's what that means. This is an equilateral triangle. Can you guys guess what an equiangular triangle means?
Equal angles.
You got it. Equal angles. So this is an equiangular triangle. Notice that all three angles are 60. Since all three angles have to add up to 180, they all have to be the same. That means they all got to be 60 because 60 is equal to 60 is equal to 60. And if you add all three of those up, you'll get 180. So this is an equilateral. This is an equiangular triangle. Now I'm going to combine these two theorems together. Here's what you should write. In fact, let's write this on the bottom. We'll put a big star here and we'll write the following. We're going to say equilateral if and only if equiangular. Period. Keywords if and only if. If you guys remember back when we did our logic section, this looked like this. Instead of just P arrow Q, it was P double arrow Q. So the first theorem over here is actually called a corollary, which is kind of like a mini theorem. But the corollary basically says, if it's equilateral, then it's equiangular. And then this theorem over here says, if it's equiangular, then it's equilateral. So let's just combine them both. So here's what I'm telling you. Every triangle that's equilateral is also equiangular, and vice versa. In other words, if we go back to this page here, if this is equilateral, guess what the measure of this angle is?
Equal angle.
Yeah, what is it though? Well, look over there. What's it got to be?
60.
It's got to be 60. Let's measure this angle.
60.
Let's measure this angle.
60.
Hey, if this guy is 5 centimeters long, how long is that side? 5 centimeters long. Does that make sense? So if I want to find 4x's, that's what we're trying to do. We're trying to find the value of x and the value of y. So here's 4x. Now clearly, what kind of triangle is this? Well, it's equilateral, right? If it's equilateral, I'll write it down. If it's you got it. If it's equilateral, all the sides are the same. Well, guess what that implies? Equiangular. So guess what 4x has to equal? It has to equal 60. That's what we just established. 4x has to equal 60. It doesn't kind of have to equal 60. It absolutely has to be 60. Do you guys know how to divide 4 into 60 in your head? Can you do that? Can anybody do 4 divided into 60 in their head?
Yeah.
What is it?
15.
It is 15. No one is on fire. 15 is the correct answer. Another way to think about that is if you've got a clock, how many minutes are in an hour? 60. What's a quarter of an hour? 15 minutes. Okay, good. Now, I found x. I found that x was 15 because I already know that this angle here has to measure 60, right? Can anyone tell me what y has to be in this problem?
180.
Does not have to be 180. That's a good guess, though.
60.
16 plus 16.
How much is that?
120.
You got it. It's 120. Here's the thing, guys. If this angle right here measures 60, by the way, what's this angle here have to be? Also has to be 60, correct?
Mm-hmm.
What do these two angles have to add up to? This angle. This is called the exterior angle. You guys remember that? I'm just going to give you a little piece of advice. If you forgot the theorem in section 3.5, we studied this theorem called the exterior angle theorem, and it says that the exterior angle, this guy, is equal to the sum of these two guys. These two guys are called remote interior angles. Do you guys remember that? I don't know if you guys can remember that. That was last chapter. So anyways, there you go. Good. All right, we got one more thing here. Marvin, will you start writing that down? I'm sorry. Okay. Last thing. I'm just going to explain this one to you. I think this is the hardest one here. This is the most difficult. So I'm going to apologize in advance. Here's what the theorem says. First of all, notice what kind of triangle is that? Triangle ABC. It's an isosceles, right? It's an isosceles triangle, clearly, right? It says, if a line bisects the vertex angle, so this line bisects it, which means it cuts it into two congruent angles, then there's two things that happen. If this is an angle bisector of the vertex angle C, then this segment right here will be perpendicular to segment AD. That means it forms a right angle. And it splits this side here into two congruent segments. So two things happen. If this angle bisector of an isosceles triangle bisects the vertex angle, then there are two things. There's one, and here's two. If you kind of think about it, it kind of makes sense, but we'll talk about that more in a second. So here's a question for you. Do you guys see this triangle right here? I'll call it triangle. You see the purple triangle I just drew? Okay. Would you agree that this side is congruent to that side, making it an isosceles triangle? Would you agree that this ray right here actually bisects that angle into two congruent angles? Yes. Great. So guess what this has to be? Guess what measure it has to be? Don't say 60. It's not 60.
90.
It has to be 90. That's exactly right, because it's perpendicular. That's what that symbol means, that upside down. Have you guys seen that upside down T before?
Mm-hmm.
That means perpendicular. So y, right off the bat, we know that y is 90. Can anyone tell me what x is?
40.
4? Yeah. So this side has to be congruent to this side. If this side is 4, this side it has to be 4 as well. Guys, that's it. I'm going to stop my video here.